thank you. So the idea behind the project is sharing of expertise and allowing the patient to enter more quickly in the health system and to have a proper diagnosis. So we would like to create a virtual expert that could help pre-diagnosis rare disease with orodental manifestation, using images from the oral cavity, panoramic X-rays, and maybe to give a first answer. Is it a rare disease? Is it possibly a rare disease? Yes, no. Which one? Can the gene behind the disease be recognized? And if you have a yes to the first question, you should reach an expert center and redirect the patient, the family, towards the appropriate center nearby his hometown. Why is it possible to do that? Because they are very precise diagnostic signatures using clinical features and I would say precision medicine, so genetic information to recognize these rare dental anomalies associated to rare disease. And this is the beauty of the teeth, I would say, because mineralization will fix in time developmental anomalies. And by looking at the teeth system, that is primary permanent dentition and all the dynamic phenomenon leading the teeth in the oral cavity, you will be able to recognize the dental anomalies, shape, number, size, structure, and direct the diagnosis towards a specific disease. Teeth are not subject to turnover like bone, for example. So really you have the clues to rare disease, at least to some of them. And the idea is to move the patients from diagnostic wandering to personalized diagnostic itinerary. So it is a solution for doctors and dentists. I mentioned about the input and output data. Why for both professionals? Doctors, they might recognize a rare disease or see medical symptoms, but they are not expert in the oral cavity and very often express that they don't know what to do with the teeth signs. Dentists may recognize that there are some abnormalities in tooth development and formation, but they may not know well how to place these abnormalities into the medical component of the disease. And then the two needs to talk together to actually reach a proper diagnosis. So we do have the data, we have the expertise, we have the possibility to collaborate with AI experts and to create this virtual assistant. So we started with the first group of disease, which is a rare disease with orodental anomalies. And the look at panoramic X-rays to identify teeth present on the X-rays, missing teeth, and to deduce maybe the name of the rare disease and the gene behind that. How is it possible? You have to understand that teeth are not missing randomly, but according to a pattern that is directly linked to the expression of a given gene. So by recognizing the pattern, then you can name a broader rare disease. So it worked very well. We worked with Capgemini at that time. We could produce this first algorithm, show that it is possible to create an algorithm, a powerful algorithm with a limited set of data, which is always the problem in the rare disease field, and move forward in the project. And we chose to move forward thanks to another funding agency who helped. This is the French Health Data Hub, and I'm grateful to them. And this time we tried to tackle another group of disease, which are rare disease with enamel abnormalities, so something that is visible with a change of color, shape, size, appearance of the teeth on a photograph. So we indeed created our data set. And I agree, it's a time-consuming process, and engage into a data challenge, offering the data sets through a platform to European competitors so that they could create the best algorithm to help diagnosing this rare disease with enamel defects. So you have to understand it's not only enamel, it's enamel with defect with epilepsy, enamel defect with nephrocalcinosis, so really broader rare disease. So we prepared the data challenge. We made it. We left 3 months to the competitors to actually work around our data set, and we are now at the time of giving the prize to the competitors. So I'm sorry, it's a bit scrambled there, but okay. So we used a platform Trustio and offered 3 prizes. You can see we had quite a number of participants and a number of proposed solutions. Well, surprisingly, the team from the University of Strasbourg, just totally random, made the best algorithm. We had 2 parts. We had the technical analysis of the algorithm potentiality and expertise. And we had the 20% analysis of its reproducibility, of its explicability, because this is very important if you want to develop a medical device and to make this virtual expert available to a larger group. Okay. And we are now negotiating with the 3 groups to move forward, develop other algorithms for other disease with dentine anomalies and bone anomalies, of course. And the 3 groups are very different. The first one is more academic. The second one is kind of an association, but they're very much, they're based in Lyon and very involved in European projects. So it would be quite an interesting project to develop with ERN members. And the other is more industry. And they were interested in doing the projects to apply their technology to this very specific data set. So the perspective of these algorithm development is really to personalize the virtual expert, to make it happen and to promote and make it available to the large group of health professionals. So it is a pre-diagnostic tool. And we will multiply the algorithm. We have to test it in real life. That's why I think collaboration will be very, very nice and obviously necessary. And also we have a part of the project where we discover new signature. And this is more in the lab because we identify very often variants of unknown significance in our patients. And we want to make sense of them and to link these variants to the diagnostic signature. So we create organoids and we introduce the variants in the organoids. These organoids mimic tooth development. And then we have some response whether the variants are or are not able to modify the cells and interfere with enamel dentine development to identify further signatures, either new genes or really variants of unknown significance, and go back to the patient with a proper personalized medicine diagnosis. So these are the keywords of the project, DiagnoDent. Really to help diagnosis of rare disease, recognize this signature, these unique dental signatures, to direct patients to expert centers, Of course, to start with the data set, we have both the signature and the genotype behind the phenotype. And we are helping patients to move from wondering to diagnostic itinerary. And I thank all the contributors and sponsors. Thank you.
Much, Agnes. That is absolutely fascinating. The eyes are a window into the soul, but the teeth are the diagnosis. Could we sum it up like that?
Sometimes.
Okay. So does anybody have any questions? And again, in the spirit of collaboration, how we might take this forward in terms of collaborating between different units.
I know my colleagues also have important data set, like for example, for patients with missing teeth. They have developed a high expertise on that. So it would be, I would be very willing to use the algorithm and test and see how accurate it is to diagnose the missing teeth, but also the gene behind the missing teeth.
So would we be talking about then narrowing it down to something like hypodontia rather than a specific dental anomaly?
For these specific algorithm, yes, yeah. It tackles hypodontia, oligodontia.
Okay.
Yeah.
So a call out to all the dentists and orthodontists in the units. Anybody, any questions?
I would like to have a question because we cooperate with process of remineralization and try new processes how to reconstruct mainly enamel. Do you think that this process identification can help us?
So is the question understanding the anomalies behind enamel formation in rare disease and the proteins that are involved in enamel formation? Enamel is an amazing structure. So many actors to lay out this exquisitely organized, strong. This is the strongest barrier that the organism formed. I think yes, because if you understand that, you can build it better, more stronger, and maybe replace it. Not yet, but that would be a good target.
Great, thank you very much.